When we want to solve a series circuit problem, one way to do it is with a method I call the matrix method. Here we have a series circuit with a 90-volt battery, two resistors, a 10 ohm resistor and a 20 ohm resistor. Let's say, for the sake of argument, that you were asked to find 9 different quantities about this circuit. You wanted to find the equivalent resistance, the total current through the circuit, and the total power being used by the circuit, and you wanted to find information about each individual resistor, the voltage drop across that resistor, the current through that resistor, and the power through that resistor. So this is a lot of information to try to keep track of. In order to do this, what we can do is we can organize the information into a little chart, which I've got here. This chart might look complicated at the beginning, but if you stick with it, you'll see that it's not actually that complicated. On each column, we have one of the physics quantities related to a circuit. We've got the voltage, the current, the resistance, and the power. And then along the side, we have different rows, one for each resistor, resistor 1 and resistor 2, and then for the total, for the circuit as a whole. Now, the way that we do this is that we can solve things horizontally. We can connect numbers horizontally by using these formulas over here. We've got Ohm's law and the various power equations, and those connect quantities going horizontally. So a voltage, a current, and a resistance along one row would be connected by V equals IR. Now if we want to go vertically and connect the different resistors together or compare them to the circuit as a whole, we have to use the series rules, the series circuit rules, which are over here. These are that the sum of the individual voltages adds up to the total voltage of the battery, that the current is the same everywhere in the circuit, and that the individual resistors add up to give you the equivalent or total resistance. Alright, we want to try to solve this problem. We can look at it, we can say, what information do I have? Well, I have two resistors, and I have a special formula here, a relationship between the individual resistors, and that's that the individual resistors add up to a total or equivalent resistance. In this case, that would be 30 ohms. Okay, so then that gives me something to work with. Now I can go horizontally here. I can solve for information about the circuit as a whole. For example, I can find the current. If I want to find the current, I can use the formula V equals IR. I have 90 volts and 30 ohms, so this tells me that I have, 3 amps in this circuit. Alright, and now I can take that information and I can say, I know that in a series circuit, the current is the same everywhere. And so I have 3 amps here, and I have 3 amps here. Alright, that's super. If I wanted to get the individual voltage drops across each individual resistor, I would go horizontally again. I would say 3 amps and 10 ohms gives me 30 volts of voltage drop across the first resistor, and then I've got 3 amps and 20 ohms for 60 volts on the second resistor. Now I can then go vertically and say 30 plus 60, that's 30 plus 60 adds up to 90, which is great. That's exactly what we would expect. Now, if we wanted to do the power as well, then we could say, here, I wanted to get the power for the first resistor. I could say power is equal to I times V. 3 times 30 is 90 watts. The second resistor, 3 times 60, is 180 watts. I could add those together and get 270 watts, or I could go horizontally and do 3 amps times 90 volts, doing these guys here, and get the 270 watts. Doing it both ways, horizontally and vertically, gives you a way of double checking your work. Alright, here's another example. here's a series circuit with 3 resistors. I have a battery with unknown potential. I have a resistor R1 with 10 ohms, R2's got 40 ohms, and R3's got 70 ohms. And I've got a total current of 2 amps, or rather current in R3 of 2 amps. All right. If I create the chart here, here's the chart with the individual resistances written into it and the current in the third resistor written into it. I can start by using my current rule and say that there's 2 amps going through everything in the circuit. And I can use my resistance rule to say that the total or equivalent resistance is the sum of the individual resistances. So 70 plus 40 plus 10 is 120 ohms. Then I can look at the individual voltages. I can say, 2 amps times 10 ohms, that is 20 volts. And then 2 amps and 40 is 80 volts. 2 amps and 70 is 140 volts. And let's see, I guess we're going to have 240 volts, which I can get either vertically by adding these together or horizontally by multiplying those. All right, if I was to do the power, I've got 2 amps times 40, or 2 amps times 20 volts is 40 watts. And then I've got 80 volts and 2 amps, that's 160 watts. And I've got 280 here. And I add those together. I say, I get 480 watts total. And again, I can get that either from these 3 added together or from these 2 being multiplied together. It's a good idea once you finish filling out the chart to do at least 1 or 2 sort of side cross checks by seeing if you get the same answers going in a different way. That gives you a little extra confidence that you haven't messed something up.